Which trends are you following in the MDAM or machine-to-machine big data today? Gert?
Tend to be the first one here. Well, with trends, I try to separate a little bit trends that we are observing from verticals and applications that we are chasing with our investments. So some of the underlying trends that we are observing is, it's called big data, but the key enabler behind it, I think, is actually communication technologies, which have moved from just a human being to anything else, whether it's a human being or a machine or vice versa. It has evolved to machine, and we have, I just picked up the number, 10 billion devices connected wirelessly as of today. That's at least the number published by ABI Research, and forecast to grow to 30 billion by 2020. So really an explosion of IP-connected devices. I think that's a key enabler or a key driver behind big data, because that allows us to collect all the data and then try to make sense out of data.
I'm sorry, it's published by whom?
That was ABI Research. But then bear in mind, communication is not the application, and communication is an enabler, and you have to put something else on top of it to really extract value out of it, and quite often data gets confused with information, and I think a lot has to happen with the raw data that is collected in terabytes and petabytes by now, to really extract meaningful, actionable information out of that. Once you've run the analytics over it, it's still not done, and that's another trend we are observing right now, and that is, how do you really present the data that you've been analyzed, so the information you've extracted out of it. So that's the visualization and presentation aspect of it. And both the communication and then the data integration or data fusion, if you want to call it, and then the visualization presentation, I would consider that as key enablers for the whole big data space, because that's something that you need across all different verticals. Coming from Germany, privacy is a bigger issue over there than I would say over here, but it's something that needs to be looked into, needs to be dealt with. And closely connected with that is also the IT security aspect, and I think that is getting quite a bit of attention lately. There has been a report by the US Senate, for example. FERC Chairman Wallinghoff has been talking about it a number of times. So those are some of the topics or trends that come to mind.
Great, thank you. Hiten.
All right. So talking about machine-to-machine communications, or as we call it, the Internet of Things, we basically think about devices, right, which are basically out there talking to each other. In some way, they're even controlling certain aspects of our life or an area. So ultimately, if it's these devices that are talking to each other, they're sharing information. Right, this information obviously is flowing somewhere, right? It is getting consolidated for maybe in any vertical, right? Like if it's energy or utilities, we talk about smart grids. We talk about these, intelligent, pole top routers, that talk to your smart meters, and they send the information back to your, data centers, right? So ultimately, where and I'm sure other industries have their own, kind of specialized cases where they use data in that way. But at least in the energy and the utility, you've seen that once the information comes back to the business, it just stops there, right? It stops at the data warehouse. And when the business is trying to use this information, right, for effective decision making, there's a lot of manual processes that they will go through, because of which the data that's there, it's really of no use, because it can be accessed in time by the right people, right? So by the time they get the data, it's probably too late, or something's moved on, because of which they just can't use it to make the right decisions. So going back to the point is, big data actually it's not about handling the volume. It is in technical sense, but it's more of a shift in the paradigm for business decision making, right? As to how is this information really used, right? How are organizations going to use this information to get better insight, to either improve their operational efficiencies, or be able to use it just for primary reporting internally, right, or externally. There are a lot of regulatory mandates, right, especially in industries like energy and utilities, where they're bound by it, right? And you got to do this in the right way. So security plays a very important part, right? Governance of the whole platform, right? Talking from operations to architecture, all right, is another key part, right? That's where we are also focusing on. So I think ultimately, both of them have a true sense of a blend, right? One is basically, the source of data, and then the other one, is the technology that is going to enable organizations to make good use of it for better insight and decision making.
Great, thank you very much. What
I think that's
are some, is there a question?
Yep.
Yes,
So
go ahead.
in machine-to-machine space, are there standards evolving? For example, if I wanted to build an application that talks to smart meters from multiple vendors, do I have to learn about each and every vendor, or is there a standard that I can use to talk to?
Well, so there are standards as they're coming along, right? If you look at the kind of smart grid, the standards that are coming, like OpenADR, OpenSG, right? But again, like, it depends on which area you talk about. If you are in the HAN, or which is the home area network side, where they're trying to basically kind of make Zigbee the standard for the in-house controllers, right? Talking to meters, and so there are standards that are there, right? But as far as being able to use it, it's again a debate, because there are utilities which prefer to go with the standard Wi-Fi kind of way of connections, and kind of overlaying its security. But yes, so the standards are there, although they are evolving. It's going to take some time to settle down to kind of bring it to a point where it could be said that yes, this is the way that we would be talking to the meters, and this is something which the vendors can leverage.
Okay. Thank you.
What do you see are the key pain points that M2M is helping PG&E specifically solve?
Okay, so basically this is mainly about, like I said, first of all, making intelligent decisions based off, kind of like, if PG&E is trying to roll out a program, right? For example, in demand response and energy efficiency, they get to a point where they know how to implement it, but when it comes to seeing how well it's running, right? So maybe in sense of energy audits, right?
Right.
So when you get onto pgne.com as a customer, right, and you get redirected to OPower, right, which is a third-party cloud-based services provider that helps us, kind of consume the residential data, perform some analytics, and show you different trends, right, as to how you're consuming or how you're basically using energy, how you do well against your neighbors, and things of that kind, right? So getting all those custom analytics done is something which PG&E is focusing on and has not been able to do as well in-house. So I'm sure organizations in other verticals too look at the best of the breed out there, right, which is third-party vendors which have already developed such solutions, which can help industries for either point-specific solutions or maybe broader initiatives, right? Another area is on energy efficiency, where we are trying to kind of use all this audit information that the customers feed in and actually bring it back. So it's actually sending it to third parties, right, performing analytics and getting it back to qualified further, right, to perform analytics on top of it, so that you can basically extend your energy efficiency programs further into other verticals like large customers and industrial customers, or SMB customers.
Oh, interesting. Great. Thank you very much. Brian?
Yeah, and just real quickly, I'll hit your question about standards. So standards is probably the number one thing holding everything back. If you look at I wouldn't say it's mature yet, but if you look at a vertical such as utilities, it's absorbed a lot of both venture and also just corporate investment. You see the standards emerge, OpenADR, for example, in building controls. But the vast majority of the machine-to-machine world is operating, it's very Wild West. The communications modules that people are designing into products and machines, the aftermarket things that you attach to machines to monitor existing things that are out in the world, it's just unbelievably fragmented. Operating systems, technology stacks on there. I'm actually working with Oracle a little bit to try and push lighter weight versions of Java down to devices as a standard, but that's going to meet some resistance. And there's actually there was a task force just formed last week with an Oracle person, someone else from a company called Digi, a couple others that we're working with that's going to try to start tackling this, and it was just announced at CTIA last week. But it's a really big problem, and it can't be understated. IBM's trying something with MQTT, which weirdly enough is actually used a lot by Facebook for a lot of things. It's a major issue, like without a doubt. I mean, if you're investing in the space, you really need to look at where the standardization hurdles are, as well as some of the security hurdles are around different areas. In terms of trends, so for us in our practical sort of day-to-day existence, the thing that I'm trying to keep a really close eye on is machine learning. So there's a couple startups that have popped up across the country. There's one in Berkeley called Wise.io, and there's another one out in the East Coast called Grok, that are basically developing cloud-based machine learning services. So our end customers' fundamental problem is that when they turn the spigot on from a machine, the signal to noise ratio is unlike anything they've ever seen, and they tend to be electrical engineering oriented folks, and so they want all the data. And so you'll get, let's just say 10 gigs of data, and only 1K actually tells you something significant. And compared to like traditional data mining in like a marketing situation, in a retail environment where you're just looking at POS data, et cetera, there's a geometric difference in the signal to noise ratio problem there. And so, so I'm actively right now trying to identify and pick my own winners in terms of partners in the machine learning space, because we can get all the data. I can do baseline, essentially real-time analytics and stuff, but and I can store petabytes of data, but at the end of the day, with product life cycles being what they are these days, and also people just connecting things so fast, human beings can't possibly analyze all this stuff. And fortunately, the people who really know how to look for the trends within the data, there just aren't that many of them. So you think of a product engineer from somewhere like Siemens or GE, there's that knowledge is kind of trapped in their head. So you really do need to take their knowledge and ideas about what's going to happen and then put it into some sort of machine learning algorithm and let it go. Because there's just not enough time to get through all the data and make it valuable. So that's a big trend that we watch. And just at a macro level, the other one that's really critically important for our business is just hardware costs. So wireless communication modules, Moore's Law kicking into effect on both Wi-Fi modules as well as cellular modules. We're near the precipice of true throwaway sensors, which will open up whole new killer apps that are out there that are sort of just waiting in the wings.